Hello, everyone. My name is Michael, and today I'll be talking about perpetual motion machines and their role in the future of society. And together with me is my dear friend, Professor Phil. Now, you might notice that Professor Phil seems sad and disappointed. But why is that? Well, a long time ago, Professor Phil started to do research on how to build the perfect perpetual motion machine. But after many years of trial and error and broken prototypes and lots of stress, he realized that building this machine would be impossible. But what are perpetual motion machines? A perpetual motion machine is a theoretical apparatus that, given an initial push, would run forever. There have been many attempts to build a perpetual motion machine. The first one was in the 13th century, and many more, like the ones shown on screen, followed. Even the great Leonardo da Vinci gave it a shot, and failed as well. The search for this machine has been so fruitless that even the US and British patent offices reject people claiming to have built one. But why are these machines so evasive to us, science and engineering? The answer to that question lies within thermodynamics. Thermodynamics is simply a branch of physics that studies the behavior of heat, temperature, and work. As they will show on screen, there are three universal laws of thermodynamics. Nevertheless, only the two first ones challenge the quest for the perfect perpetual motion machine. Remember that perpetual motion machines are only useful if they move forever, and to do this, no energy whatsoever can be lost from the system to outside sources. The second law of thermodynamics, however, states that the amount of disorder or entropy in the universe is always increasing. Some of the energy will always be lost to friction, air resistance, sound, etc. Is this the only reason that these machines cannot work? The answer is no. The first law of thermodynamics is the law of conservation of energy. No energy is ever lost or created, but transformed from one type to another. How is this related to perpetual motion machines? Well, if some energy is always lost, and this energy can't be made up for, then the system will never be 100% efficient, and thus, it will eventually have to come to a stop. But don't give up yet, Professor Phil. There's still hope for a perpetual motion machine, and curiously enough, it comes from the third law of thermodynamics. The third law of thermodynamics was discovered in 1848 by Lord Kelvin, and it states that the minimum temperature for any object is negative 273.15 degrees Celsius, or absolute zero. In this state, particles have no kinetic energy whatsoever. No matter how good your technology is, you can never reach absolute zero, much like the speed of light. How are these two connected? Well, perpetual motion machines need to be 100% efficient. Absolute zero is the only state in which energy is never lost. Now, can we make a connection between these two happen? The answer is no, we cannot. Nevertheless, there is an indirect way of connecting these two concepts, which are Class 3 perpetual motion machines and superconductivity. So far, we had discussed Classes 1 and 2 of perpetual motion machines, which attempt to violate the first two laws of thermodynamics. But what if I told you there's a third type of perpetual motion, when electrical resistance is brought down to zero? Superconductivity is the reason why. Superconductivity is a state in which materials can conduct electricity with no resistance. If it is achieved, electricity transportation will be 100% efficient, with no energy loss whatsoever. Now, what is the cost of superconductivity? The answer is near absolute zero temperatures, which is when metals hit the critical temperature and become superconductive. This all connects because by applying near absolute zero temperatures to materials, their atoms slow down, reducing energy loss. With this, they become superconductive, making electricity conduction 100% efficient, which is also called Class 3 perpetual motion. This would bring many benefits to the economy. Energy transportation would be free of cost and 100% efficient. By using superconductivity, magnets much stronger than the Earth's could be created. with applications in transportation and carrying heavy objects. Now, to wrap things up, I want to touch on a very important question that even Professor Phil was asking himself. Should science give up on the quest for perpetual motion machines? The potential of perpetual motion machines is huge. Capable of being 100% efficient and outputting limitless amounts of energy, it could be the revolutionary invention of the modern age and the solution to our current energy problems. As Michio Kaku puts it, perpetual motion machines are considered class 3 impossibilities. Given our current understanding of the universe, they cannot be made. Yet, you can't give up yet, Professor Phil. As Arthur C. Clarke's second law puts it, the only way of discovering the limits of the possible is to venture a little way past them into the impossible. Thank you very much.